Continuing with chapter 9, here is lesson 3, where we were talking about real-world problems and graphing. So you're making linear graphs, likely, or also known as a straight line graph. So this is where you should have used your linear equations from chapter 8 and then be graphing them on the coordinate plane here. So we're going to be on page 62 is where chapter 9, lesson 3 starts. And then we're going to be actually doing a problem from page 65. So if we look at number 1 on page 65, you can read it. It says, a cyclist took part in a competition. The distance traveled, d meters, after t minutes is given by d equals 700 t. Graph the relationship between t and d. Use 2 units on the horizontal axis to represent 1 minute and 1 unit on the vertical axis to represent 350 meters. So then you can see that we have the chart. So there's time, which is t minutes, and distance, which is d, and then meters. You can see they have 0 and 0, and then 1 and 700, 2 and 1,400, 3 and 2,100, 4 and 2,800. So you can see our unit rate right here of 700 meters per minute. Okay. We also have our equation that they gave us in the problem of d equals 700 t, which we can see from our unit rate, that the distance is equal to 700 times t. So if I had 1 minute plugged in here, I'd take that times 700, which would give me the number of meters of 700. That's how the equation works. And then they told me how I need to mark my graph down here. So this is 0, 0, the origin, obviously. And then it says on the horizontal axis, I'm using 2 units to represent 1 minute. So that means these here, these 2 units are 1 minute. So this would be 1/2. So this is 1 and 1/2. So this would be 2. So you just need to relabel your graph. So 2 and 1/2, and this would be 3, 3 and 1/2, and the 8 would be 4, and then 4 and 1/2. And then we need to label that with time, which was t minutes. And while we're doing that, you need to have a title for the graph. So we could put like cycling competition. And then we also have our distance over here on this side, which was d, and meters. And then in the problem, it told us on page 65 that 1 unit on the vertical axis should represent 350 meters. So 1 unit over here would be 350. So that means 2 would be 350 plus 350, which is 700. And then plus another 350 would be 1,050. Plus another 350 would be 1,400. Plus another 350 would be 1,750. Plus another 350, 2,100. Plus another 350, 2,450. And then another 350 is 2,800. And then a final 350 above that would be 3,150. Okay. So, and then it says the directions on the page say use graph paper solve. So it says what type of graph is it for A. And the first thing that you're going to have to do is actually graph it. So here at 0, 0, I need to plot that. If I don't know how to plot that, using your table, the 0, 0, I can make coordinates. So I have 0, 0. And then I have 1 and 700. And then 2 and 1,400, and so on. 3, 2,100, 4, 2,800. So I have a 0, 0 that I need to put a point at. And then 1 and 700. And then connect those with a straight line. And then 2 and 1,400. And then 3 and 2,100. So you can see why it's important to make your X and your Y axis labeled correctly. 4 and then 2,800. So by this point you should see that it's a linear graph or a straight line graph, which also tells me I have a linear equation. Okay, and then it says, what is the distance traveled in 2.5 minutes? So I can use the distance formula for this, where I had distance equals 700 times the time. So the distance traveled in 2.5 minutes, I would plug in 2.5 here, and then multiply that. It should match to what I get on my chart here at 1,750. So take 700 times 2.5 either on your calculator if you have one, or you can do it with long multiplication if you didn't get a calculator and you weren't for math. So it should be 1,750 meters. And then C says, what is the distance traveled in 3.5 meters? So again, you can check with your chart. There are some where it won't work because you won't have the number there. So the distance on this one you can tell with your chart, but you can also plug it in to the formula just to make sure. So 700 times 3.5 is 2,450, which matches on our chart as well. And the label would be meters again. And then D says, what is the average speed of the cyclist? So this is where you pull in another chapter, and distance is on our triangle here where we have distance, speed, and time. And we're looking for speed, and that would be distance divided by time. So I can pick any of my table amounts, any of my points on this line. It doesn't even matter if it has a dot, it just has to be a point on the line. And I can take the distance, so like 1,400, divided by the time for that same dot right there is 2. So 1,400 divided by 2 is 700 meters per minute, which you'll see in your chart. You already have your unit rate, so you could have just gone straight to your unit rate for the speed. But it's always good to know that you can use your speed formula as well. And then E, assuming the cyclist travels at a constant speed throughout the competition, what distance will he travel in 7 minutes? So I take the speed, so now I have my distance formula, because 7 minutes would be off my graph. So what distance, I'm looking for speed times time, so I have 700 times, the time they gave us was 7 minutes. So 700 times 7 would be 4,900 meters. And then finally F says if the cyclist needs to cycle for at least 2 1/10 kilometers, how many minutes will he need to cycle? And so you're going to express your answer in the form of an inequality. So I have 700 which is my distance, t, so I have my formula. And the cyclist needs to cycle for at least 2 1/10 kilometers, so that's the distance. And then I'm looking for the minutes. So at least doesn't just signal greater or less than, it signals greater or less than or equal to. So this is the amount that's the minimum. So I can solve this. I could divide by 700. If I want to make it easier on myself, this is what they just gave me was 2.1 kilometers, and I have a speed of meters, so I would need to convert this to meters, which would be 2,100 meters. So then I can divide by 700. So you're solving the inequality just like an equation. So 2,100 divided by 700, you end up with, you can simplify it by dividing by 100, and then you end up with 21 divided by 7 is 3. So the time has to be greater than or equal to 3 minutes in order for them to get to 2 1/10 kilometers. And then G is our final one. Name the dependent and independent variable. So the dependent variable is the D, which is the distance. We know that because of the formula where if we multiply the time times something, the distance will change. And the independent variable would be the time. We also know that because the time is on the x-axis. And that is how to make a linear graph using a linear equation.